Combustion reactions. Hydrocarbons are the result of glucose or the products of glucose breaking down over time and pressure. The oxygen in glucose is removed and the carbon and hydrogen form molecules with differing numbers of carbon and hydrogen. This results in methane, natural gas, oil, coal, and other hydrocarbons. Energy from the original glucose molecule, which was derived from sunlight, remains in the hydrocarbons. That energy is then released in combustion reactions. These are generally rapid reactions that produce a flame. They most often involve hydrocarbons reacting with oxygen in the air, which is what we will consider in this course. Oxygen is always one of the reactants. One product of combustion will be either carbon dioxide, or if there's insufficient oxygen to react, carbon monoxide. We will assume oxygen is available, so a product will be carbon dioxide. These are examples when there is sufficient oxygen available as a reactant, so carbon dioxide is a product in both cases. So over here we have methane plus oxygen, and here we have propane plus oxygen. If the reactants are a hydrocarbon and oxygen, it is a combustion reaction. Combustion reactions always take this form. We have the hydrocarbon, we have oxygen, and it forms carbon dioxide and water. Of course, this is assuming you have sufficient oxygen available. So write a balanced combustion reaction for C4H10, that is butane. Balancing this reaction may require multiple steps. First balance the carbon and hydrogen, then the oxygen, and the answer will be on the next page. First, balance the carbon and the hydrogen. Well, we look at the left, we have 4 carbons, so we want 4 carbons on the right, so we put a 4 in front of CO2. We have 10 hydrogens, so we put a 5 in front of the water. Next, we balance the oxygen. Let's look at what we have on the right side in terms of oxygen. We have 4 times 2, so that's 8, and then 5 times 1, 5, so we have a total of 13 oxygens. On the left, we just have 2. So how do I get from 2 to 13? Well, 13 over 2 is 6.5. But we're not done. We can't have half of an oxygen molecule, so you need to double all the coefficients. So here we go. We double the 1 and we get a 2. Double 6.5, we get 13. Double 4, we get 8. Double 5, and we get 10. So here's our final balanced combustion reaction.